So what we're going to do here is learn how to use the periodic table to write electron configurations. Now what you have to remember is that this is the S block, these two groups here, although this is one exception. This is also 1s. Little guy right here, helium, is 1s. So here's our S. Our F is normally pulled out of the periodic table, but this is an extended periodic table, so it's in there. But it's going to make everything in the boxes really, really, really small, so it's hard to read. So people like to pull that out and put it at the bottom. This is the D block. These 10 columns over here. Oops, I overshot that a little bit. This is the D block. And then finally, back to, let's go purple here, the P block. So this section up here is the P. Now, if I ever forget how many each of these blocks can hold, I just count. 1, 2, 3, 4, 5, 6. P's can hold 6 max. D's can hold 1, 2, 3. You count them all, you get up to 10. F's can hold a grand total of 14. If you count them all, it's 14. And S can hold just 2. So if you ever forget how many electrons can be held in a sublevel, just look at your periodic table. It tells you that. It also tells you where you're going to end. So my argon, I'm going to do argon first here. Argon is found right here. It's element 18. So it ends in the third row. 1, 2, third row in the P section, and it's the last P. P1, 2, 3, 4, 5, 6. P6. So that's what the last thing I write on my paper is going to be, 3p6. I just have to figure out what everything else is that comes before it. Now, in order to get here, I've got to pass through the 1s, and it's filled, so I write 1s2. Then I go to the second row of the periodic table, 2s. Whenever I come to the end of a section or a sublevel, I record how many electrons are in there. Then I get over to here. Now I'm in the second row of the periodic table, but the P section, and it's filled. I go right through it. Oops, so it's 2p6. Then I'm back here in the third row of the periodic table, 3s2. Then I go over here, I jump across, there's nothing in the way. I get over here, and I keep going until I bang into my 18. That's my argon, and that ends in 3p6. So there's my electron configuration for argon. And argon has 18 electrons, so if I count 2 plus 2 plus 6 plus 2 plus 6, it all equals 18. That's how you can check yourself. So there's the electron configuration for argon. Now let's do iron. Iron's got 26 electrons, so what you need to do is find iron on the periodic table first. So let me clear off this mess here. And if I find iron, I realize that it's in my D block. And D's are a little tricky. They don't follow the rules all the time. Now iron is going to be over here, 1, 2, 3, 4, 5, 6. This is iron, element 26, Fe. So what I'm going to do is same thing. I'm going to count all the, or record all these sublevels until I get to here. So let's start. Got a long way to go. So I first fill 1s2. Then I'm back here at second row. I pass through the 2s, fill it with 2. Then I jump over all this space. I'm over here still in the second row, but this is the P block. P can hold 6. If you forget that, just count. Now I'm in the third row, 3s, 2. Then we go over here, third row, P block. 3p can hold 6. Now, watch what happens after 3p. I don't go to 3d. 3d is over here, but in order to get here, I got to pass through 4s. Remember the 4s seats were a little bit cheaper, and they were a little closer to the theater? So 4s2. Then I hit my 3ds. 3d. 1, 2, 3, 4, 5, 6. 3d6. And that is my electron configuration for iron. And if I count 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 6, I equal 26. So that's how I know I did it right. Now notice threes, or the D's rather, are always one behind. This is the fourth row of the periodic table, but this is 3D. This is 4D. This is 5D, 6D. D's are always one behind. Just remember that. All right, let's do iodine. All right, so iodine is right over here, element 53, and it's in the P block, and it's 1, 2, 3, 4, 5, 6. 6p, and it's almost at the end. It's not 6p6, but it's 6p5. So 6p5 is where it's going to end, right there. That's the sixth row of the periodic table, P block, and it's the fifth. 1, 2, 3, 4, 5. So I'm going to keep going until I get there. Draw my little lines on the periodic table. 1s2, summarize whenever you get to the end of a section. 2s2, jump across. I'm in the P block, second row, so it's 2p. They're all filled, 6. Third row of the periodic table. 3s2, jump across all this nothingness. Get over here to 3p. 6. Now after 3p6, not 3d, we hit the 4s first. 4s2, jump across nothing. Now we hit the D block. Remember, this is the D. D's are always one behind. That's the rule. 3D. And it's filled with 10. If I forget, I count. There's 10 columns. Then I get back over here to the P section, and I'm in the fourth row. 1, 2, 3, 4. Fourth row, fourth period means I write 4p6. After 4p, I jump over here to the fifth row. 5s2. Getting closer, skip over all this. Now I hit 4d. I'm in the fifth row, but d's are one behind, so it's 4d, 1 through 10. Then I get to the 5p, back to the normal periodic table. 5p6. Now I go over here to the sixth row, and I hit 6s2. Then look at what happens. I'm in the F block. This is the F, 1 through 14. Now F's are always 2 behind, so it's the row or the period minus 2. D's are the row or the period minus 1. F behinds are F's are 2 behind, so subtract 2. So if I'm in the sixth row, this is 4F. If I'm in the seventh row, this is 5F. 7 minus 2 is 5. So after 6s2, I hit 4f14. All of these guys are filled. Then I get back to the D section. This is 5D. Remember, I'm in the sixth row, but 5D. 5D10, all the way to there. And then I finally hit my element that I'm dealing with here, iodine. So that's my sixth row, 6p5. So there's the electron configuration for iodine. Now let's look at the regular periodic table. Normally, this is how you see the periodic table. These two F block rows are pulled down. And what you need to remember, this is the 6th and the 7th. That makes these guys 4F and 5F. They're always 2 behind. And the D's are always 1 behind. So if this is the fourth row of the periodic table, fourth period, then this is going to be 3D. And this is 4D, 5D, 6D. So let's see how we use the regular periodic table to do radon and borium. So radon's 86, and I find radon all the way over here, 86. So I got a long way to go till I get there. So 1s2, 2s2, jump over here, 2p, 6, 3s2, 3p6. Beginning of the row here is the 4s block, fill it with 2. Now I hit the D's. 3D10. They're all filled. 3D10. Back to the fourth row of the periodic table. P's or whatever row you're in. 4P6. Back to the fifth row. I hit 5S2. Still a long way to go. 4D10. Then I hit the fifth row. Back to the P block. S's and P's are always in whatever row it's in. So I'm in row 5, so it's 5p6, 6s2, and now it gets tricky, because before I hit 5d, I got to drop down here. Everybody see that? Before I hit 5d, I got to drop down and take care of this. So 4f14. Then back up here. At the end, I go back up to right there, and I pick up 5d10. Then I'm back in row 6. 6p6. Over here, 7s2. Watch what happens. I drop down, before I hit the D's, I drop down to 5f's. 5f, and there's 14 columns, 14 groups, and then I can go back up at the end. I go back up to where I picked up, right here. 6d, 10, and then finally 7p6. I'm in the 7th row. Let me get red here. 1, 2, 3, 4, 5, 6, 7. 7th period. I'm in the P block, and I'm in the last column, so 7p6. So that's what I should end in right there. Now, the good news is, this is a little crazy. We're only going to do a couple of these long ones just to make sure you know how to do it. But there is a shortcut coming, so just kind of bear with this process in a minute. But you have to understand this whole process for the shortcut to make any sense. All right, let's do borium now. Let's erase all this. Okay. So borium is going to be over here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So this is BH. There's borium. So we're going to keep going until we get there. Now the question is, where is there? This is the D block, so I know it's going to end in D. This is 1, 2, 3, 4, 5, so it's D5. And you have to remember that D is always going to be 1 behind. So whatever regular row or period you're in, 1, 2, 3, 4, 5, 6, 7, it's always going to be 1 behind. So 7 minus 1 is going to be 6. So I'm going to continue on until I get to 6d5. But it's down there. I've got quite a bit of electrons to place, so my electron configuration is going to be pretty long. But let's use the periodic table. It'll guide us. 1s2, 2s2. Jump over here, 2p6. Start at the left, 3s2. Keep going, jump over all that, get to 3p6. Back here, 4s2, not 3d, 4s2. Then I hit the d's. D's are 1 behind. So if I'm in the 4th row, this is 3d. 3d10, because I go through all these guys. Then I get back to 4, and I'm in the P block, so 4p6. Then I go over here to 5s. Then I hit the d's, 1 behind. I'm in the 4th row, so it's 4d10. Then I'm back to the normal. I'm in the 5th row, so it's 5p block, 5p6. Then I hit 6s2. Then I hit the f's. See what happens here? Once I get to this point, I got to drop down, and I got to do the f's. Now the f's are 2 behind. So if I'm in the 6th row of the periodic table, this is going to be 4f. So I'm going to pass through all the 4f's. 4f, and there's 14 of them. If you forget, just count. At the end, you're going to go back up and pick up where you left off. This is the D block, and it's 1 behind, so it's 5d. So 5d10, then we're back to normal. 6p6, almost done here. 7s2. Then before I get to there, I got to drop down, and I got to do my 5f's with 14. When I get to the end of my 5f14, then I pick up right here, where I left off, where I drop down. I go back to that same spot, and then I move over till I hit the element in question. 1, 2, 3, 4, 5. So I'm in 6d5, which is what I thought when I first looked at the periodic table. So there's the electron configuration for borium.